to find your inverse, you're going to interchange your x and your y. When we get to an inverse, what we're hoping for an inverse is that it's a reflection of the lesser over the line y equals x. The rule for this transformation is just swapping those two positions. Here's your line y equals x. It cuts through the first and the third quadrants. If you, for instance, had a point up here, 1, 5, when you reflect it across the line y equals x, it interchanges this to 5, 1. So your rule is interchange your x and your y. We could see that in an equation. We could see that in a discrete data set. You take these and you interchange, and then your new set of data has to pass a function test. So in order for us to look ahead, instead of having to switch just to see if they're a function, we can also look at this backwards. That if any y repeats itself, you're not going to have an inverse. Because to be an inverse, you have to pass a vertical line test on your original function, where every x has one and only one y, and you have to pass a horizontal line test, where every y has only one x assigned to it. So it's got to have both of those to be able to do this. Another thing that happens, if you notice, because you switch the x and the y, the domain and the range switch as well. Whatever the domain was for the first function, when you make the inverse, it swaps. So here's your domain for this guy. Your domain is 1, 2, 3, 4. And your range is 5, 6, 7, 8. Notice when you swap them, your domain, which was an x, goes to a y, which is your range. Your range, which was a y, goes to the x, which is a domain. So now your domain swaps with your range. The x and the y interchange. And now your range becomes what your domain used to be. Remember doing this in Algebra 2? You kind of hit it briefly. We did a little bit with inverses, not too much. This is important to remember that your domain and your range swap. You probably remember this from trig. In trig, we had to cut a little piece of your curves to make it a true inverse. Remember in trig, here was your sine curve. This will probably make a little bit more sense. And you said, if we make an inverse out of this, it doesn't pass a horizontal line test. So remember, we restricted your domain. We restricted your domain from negative 90 to positive 90, so that we could only see that piece as a function. So you want to make sure that your original function passes a horizontal test as well as the original vertical. Okay, it's got to pass both. Now, to interchange your equations, to find that to interchange your equations, I gave you a sheet that would kind of help you figure out how to interchange your equations. I gave you a good example, but here's another one. See what the inverse equation would be. You're going to interchange your x and your y. So this is your y. These get interchanged just like the xy goes to yx. So we put the x. And in an equation, you always solve for y equals. So you solve for your new y equals, and you get your inverse equation. You get your inverse equation. We replace y with f to the negative 1. This tells us inverse. Who knows? Pretty fancy, huh? That's my eye. Yeah, it is. That was the straightest line I ever made. That's my inverse, f to the negative 1. So whenever you take your equations and you interchange your x and your y, and you solve for your new y, you're going to make it say f to the negative 1. So this kind of shows you, here's two equations that are inverses of each other. Their domain and their ranges swap out. one swaps out to the other. Now, on a calculator, this is also nice to see. If you take your original equation, x plus 4, and you take your inverse equation, x minus 4, and then over here, make your line y equals x, watch what happens. You'll see the inverse. You'll see the reflection over the line y equals x. Here's the first one. Here's the inverse. And there's your y equals x. See the reflection over that line? It won't always be as clear as that, because sometimes your lines will cross, sometimes you'll have a parabola, and we have to restrict part of it. So, just so that you can pull that up and see it. You can also go to your table, and you can tell by your table your values. Your -5, -1, you should see one that says -1, -5 for this one. -1, -5. See it? Those points have to interchange. That's another good way to tell. Look at your table. -4, 0. You look for the 0. We're going to see 0, and in the second column, we're going to see -4. 0, -4. See it? So those points are all interchanging. Your domain of one becomes your range of the other on an inverse, because your rule is interchange your x and your y. Okay? So just a little on inverses. And another way we can tell this is if we do f of g and g of x. If we take these and we do a composition of this, and then we swap it, we do a composition of this, they use the inverse notation. If you take your inverse, say these, and you do it like this, they should come to the line y equals x. Both of them should be y equals x. That's next. My border's off on the side. So we're going to take this, we're going to create the inverse, and we're going to do g of f and f of g, or f of f to the -1, f of -1 to the f, and we'll be able to see that a little bit better. So let's take this and work with this. So I have a cubing function and a cube root. I want to see if they're inverses of each other. The first thing I could do is graph it and see if I see it in my table. So I'm going to take my calculator and I'm going to graph it. Do it by a visual. Let's do it graphically. So the first graph is x cubed -1. And the second one, if they're inverses, we should see it. We have cube root Okay, so let's see in fact if they're inverses of each other. Oh, my first. Okay, try. Here's the first cubing function, and here's the cube root function. And here comes my line y equals x, smack in the middle. Can you see the reflection over the line y equals x? These guys reflect. X and y interchange. Take a look at your table. For -1, -3, if we see -3, we should see -1. There's your inverse. Now, algebraically, you have to interchange your x and your y. You would take this guy, make it a y, interchange these, you'd come up with that equation. But since we have the two equations, we're going to do f of g of x and g of f at x. And we're going to see if they come out to equal x. They should come out to the line that you reflected over, the line y equals x, since they gave us the two equations. And both of these have to be done, because what you're doing is you're interchanging your domain to your range, and your range to your domain. So we take this g, and we put it into your f, wherever we see x. It looks bad, but if it's a true inverse, it really goes in pretty nicely. So this entire thing will fit into this x. Notice you're cubing a cube root. It's like squaring a square root. It gets rid of that and it comes right out. And we still keep the -1. Now, when you make a fraction, this is one term, and you're multiplying it, you can cancel out your denominator. You don't have to multiply top and bottom, just cancel one out. And you get x plus 1 minus 1. Out comes the 1s, and you're equal to y equals x. So the first part is good. It's a reflection over your line, y equals x. Let's do the second part. You're going to take your f function, and you're going to put it into your g. These both have to work if these are true inverses. You're going to take this entire thing, and you're going to place it into that x. You're going to leave the cube root sign there. Don't forget to keep your +1. And you're going to reduce. The 1s come out. What happens to the 2s? They cancel. So you're at the cube root of x cubed. What is the cube root of x cubed? X. So there's another one, y equals x. So if you can prove that your g of f and your f of g come down to the line y equals x, you have a true inverse. And a lot of times they write it as, well, they were asking us to test this. So if in fact they told us that that was an inverse, they would do the same thing, f to the -1 at x, and f to the -1 at x. Those two compositions have to come out to be y equals x. And you know you have true inverses. You can put them in your graph, you can check the table, you can look at your line y equals x, and your domain of 1 and your range of the other interchanged. On a cubing function, you really don't have to worry about it, because on the cubing function, what's your domain? All real numbers. What's your range? All real numbers. So can we see that both of these have all real numbers in their graphs? Both of them are all real numbers, so that's a little bit harder for us to tell there, but we know that they're both all real numbers, so that's okay. So you're interchanging your x and your y. Now, we're going to find the inverse of this guy together. So we're going to start with setting this to y. You're going to interchange, first rule, interchange your x and your y. And then you're going to solve for x, for y. And then lastly, we're going to make y the f the -1. We're going to make it an inverse. Since we're finding the inverse, it has to be the inverse, unless we make a mistake. So first step, interchange your x and your y. It's an equal sign. So I'm going to cross multiply this guy. Get rid of my denominator. I have to isolate y, I have to solve for y. It doesn't always look pretty, but it'll be okay. So we subtract 5. we divide by -3. And we're going to make this be f of -1 at x. We're going to make it be our inverse. Now, two ways. You can check this on your calculator. And we'll look for the table, we'll look for the inverse, and then we'll do f of g and g of f are our inverses of each other. So let's see if we can put this on your calculator. If I can remember it. You can use your fraction bar if you're more comfortable with your fraction bar. I know a lot of you guys are. What's the second one? Okay, so let's grab this guy and let's leave the y equals x line in there. See the reflection? Okay, if it's hard to see, look at your table. Take one point. Take an easy point. -3, 7. When we find 7 over here, this should be -3 here. So let's look down here and find the 7. And there's your 7, -3. See your inverse? Again, your domain and your range, because they're lines, are all real numbers. So when they interchange, they're still going to be all real numbers. If we do f of f to the -1, and we do f to the -1 of f, what should they both come out equal to? To x. They both should say y equals x when we're done. Because they're inverses. We found the inverse for them. So that should work. And then just replace it with your f to the -1. Remember to do that. This is your one-to-one function. When we have a true inverse, that's your one-to-one. The x's don't repeat and the y's don't repeat. No two elements in the domain correspond to the same two elements in the range. Remember you did one-to-one and you did one-to-one and you did the on thing. What is that called? Onto. You did the onto. You did the functions, the one-to-one and the ontos. I think we did them all at the same time in algebra 2. This is just your inverse. If it's an inverse, it's a one-to-one. It's a one-to-one because it passes your vertical line test. Okay. It passes your vertical line test as well as your horizontal line test. Back on. Okay, it passes your vertical as well as your horizontal. Alright. So let's take a look at another example. It's just not letting me use this at all. Restart. Alright, so let's find this inverse first. Then we're going to draw them, and we're going to see what it looks like. Okay? Is there any restriction on this guy? Yeah, he's a radical. So let's take a look at your domain restriction. We said this cannot be negative. So we're going to add 3 and divide by 2. So from 3/2 to infinity is our domain. And our range, we know what our range is going to be too, because our range can never be a negative number. So we can pretty much spot our range. So let's take a look at finding its inverse. First thing you want to do is to change your x into y. And then you're going to solve for your y. How should I get that y out of the radical?
Square.
Square. Good. Square both sides. We're going to add 3. We're going to just solve for y. And divide by 2. And make this be our inverse. Now, we're going to graph these guys, and we're going to see if they're true inverses of each other. So your original function, let's graph your original one first. And take a look at its domain before we start. Let's just take a look at this guy just to start with. And see if it has the domain we thought it had. So there's your domain. Just ignore the y equals x. When we do a calc value, and we started it at the 3/10, there's your value at 0. So your 0 right there, there's your starting point for this graph. So we know our range, and we know our domain. Now, let's put your inverse in, and see what happens here. Is it x squared plus 3? Plus 3? Now, there's your inverse. Your inverse is a parabola. Your inverse can't be a parabola, right? Because it doesn't pass a horizontal line test. It doesn't pass a horizontal line test here. But what happened is this. When you took every point of this and you reflected it, you got this piece right here, not this. So you're going to have to qualify your domain and your range, because what happens when we interchange them, it gave us a parabola. But we only wanted this piece of it right there. We only wanted its true inverse. This piece, this leg up here, we don't want. So when you do this, you're going to have to qualify this. You're going to have to come down here and swap the domain and the range. You're going to come down here and say, with the domain of 0 to infinity, your new range becomes your domain, and your domain becomes your range. It's not the range so much we care about, is it as a domain. When we graph that function, we only want to graph that part of the parabola. Just the one leg part. We don't want to graph the other part. We have an increasing part and a decreasing part. In this case, we only want its increasing part. So we have to restrict its domain on the new function, on its inverse. Now your calculator has a nice little way to draw an inverse. And I gave you the steps. Your calculator actually draws you a true inverse. So if we follow your calculator, okay, do you see on the bottom of the last page there? Draw your inverse on your calculator. Alright, so we're going to find all this, get rid of everything that you had. Let's start fresh. We're going to let your calculator draw your inverse. We're going to come up here, and you're going to put your equation in. And then you're going to go, just follow the steps I gave to you. Second program, here's your program. It's the draw key. There's your program. So second program, when you hit second program, you get draw. Now, you want to draw an inverse. So you want to come down here until you see inverse. Draw inverse, number 8. See it? You're going to hit draw inverse. And you're going to tell it, where did you put this? You put this in your Y1. So you got to tell it Y1, just like you did when you did your linear regressions. So you're going to go to VARs. You're going to go to YVARs, function, and hit Y1. So I want you to draw an inverse of my graph that's in Y1. Okay. And then you're going to press enter. Here's your graph, and there's your inverse. And your calculator draws you a true inverse. If you want to, in Y2, you could put your line y equals x. Your calculator knows not to give you the whole parabola because that's not the inverse of it. The inverse is just that leg right there. And to clear your drawing, you can go to the program thing for draw and enter 1 to clear it. If you want to clear it. So your calculator has a nice function that it gives you this inverse too.